Welcome to my video about DeMorgan's law, where we show how to simplify complex logical expressions, negate and or operators, and negate, that sucks. Hello and welcome to my demo of DeMorgan's law, where we see how to deal with logical expressions, where we learn how to hand trace them, and to develop test cases. This comes from page 126 in your textbook, Python for Everyone. It's in section 3.7. So let's get started. Okay, DeMorgan, who the law is named after, lived in the 19th century. He was a mathematician and studied Boolean logic. The case we're looking at is one that concerns shipping costs. And the idea is that if you had a company, let's say here in Colorado, and we're shipping skis throughout the world, you would probably charge more to international customers than you would for customers who live in the lower 48. And you'd also probably charge higher cost to customers who live in Alaska and Hawaii. So let's look at the logical expression first, and then I'll show you how DeMorgan's law allows us to simplify it. So here's the expression. And I'm going to do a little abbreviating. Actually, so if not, I'm just going to C for country equals, and I'm going to put U for USA. Okay, so if the country equals the USA and the state, and I'm going to abbreviate S here, and if the state is not equal to Alaska and the state is not equal to Hawaii, then we're going to charge, the high price for shipping. So this is a little hard to understand, especially with this not sitting out here. So let's break this down into its separate components. We're going to solve this sort of one chunk at a time. We're going to deal with these logical expressions. Country is the United States. The state is not Alaska, and the state is not Hawaii. So our test cases are going to be Colorado, Alaska, and we're going to include a foreign country. We're going to include Japan because they have some great snow conditions in their northern island. So let's just work down these conditions for each of our test cases one at a time. So is Colorado in the United States? That's true. Is Alaska in the United States? Yep, that's true too. But Japan is a foreign country, clearly not in the United States, so that's false. So how about Alaska? Is Colorado not equal to Alaska? Well, it's true that Colorado is not equal to Alaska. Alaska is Alaska, so it is false that Alaska is not equal to Alaska. And Japan is clearly not equal to Alaska. All right, and what about Hawaii? Well, Colorado is not Hawaii. That is true. Alaska is not Hawaii. That is also true. And Japan is not Hawaii. So this really is true, isn't it? Sorry, I messed that one up. Because Japan is definitely not Alaska. Okay, so next we need to consider how these are related. These are all related by AND operators. I'm just going to put quotes down here. So to be true, for a logical expression to be true, all the Boolean values in an expression that is related by ANDs have to be true. So this expression for Colorado is true. And For Alaska, we have one false in here, so and would give us a false. And same for Japan, we have two falses, so that's also false. But we can't forget our not over here, so we have to invert these. So this would be false after inversion. This would be true, and this would be true. So I'm just going to put this as a kind of like Python does it, or some programming language, with this exclamation point, which means not. So in other words, the result of not true is false. The result of not false is true. And the result of not false, again, is true. So this works out. Here's our higher shipping cost for Alaska and our higher shipping cost for Japan. Okay, great. So let's apply DeMorgan's law to this expression, where we're going to take this not basically out of the equation. We're going to invert our logical operators, and we're going to our relational operators and our logical operators. So let's do that. And you might want to see the textbook if this is confusing. So country then becomes not equal to USA. The and becomes an or. And some of this is just sort of just a law that you apply, like and becomes or. I'm not sure that makes sense necessarily, at least to me. But not equal becomes equal. And or equivalence becomes not equivalent. And then, okay, the state is equal to Hawaii. I think this one is a little easier to wrap your brain around. So again, we're going to consider our three logical expressions, and then we're going to combine them all together. And we're going to use our same test cases of Colorado, Alaska, and Japan. Okay, is the country is not equal to the United States? Well, that's false, because Colorado is in the United States, as is Alaska. But it is true that Japan is not in the United States. Is Colorado equivalent to Alaska? False. No. Or Hawaii? No. Although some people might wish it was. Today's quite warm, so maybe it even feels like it. How about Alaska? Is Alaska equal to Alaska? Absolutely. Is Hawaii equal to Alaska? No. No. No one would confuse Hawaii and Alaska. How about Japan? Is Japan equal to Alaska? No, that's false. And is Hawaii equal to Japan? Or is Japan equal to Hawaii? No. So, and we're going to relate these with ors. And when you relate Boolean values with ors, any value in the whole expression that is true turns the expression true. So in other words, we have all falses in this top row, so Colorado is false. For Alaska, though, because we have this one condition here that's true, this ORed set of Boolean values is true. And the same is true for Japan. So again, this checks out, right? Because we're going to charge the higher shipping cost to the places that are furthest away from Colorado. I hope this helps you understand test cases and DeMorgan's law and how to do some hand tracing to help you with complex Boolean expressions before you implement them in code. Thank you, and we'll see you in class.